Yes? You want me to collect it? Anybody else? All right, let's get them turned in, please. Anybody else? Just make sure your name's on it. All right, let's get started. Do you mind shutting the door? Thank you. Mic is on. All right, we're going to pick up where we left off last time. I'm going to give you an example here. I'd like us to find all 6 trig functions for angle given by the point. Let's go with negative 5, 12. Did you have a good weekend? You all doing all right? I just see this thing on the board here. I'm going to have to mute my microphone for this one. Okay, all right, let's get to this. All right, so how do we do this? We have a point, and then we have an angle that is given by that point. So start off by plotting the point, figuring out where it is. Negative 5, 12. 1, 2, 3, 4, 5. There's negative 5, 12. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Whatever. 12 is up here. So we've got this point here. Now the angle we're talking about is the angle that's formed when you connect this to the origin and call that angle right there theta. Now we need all 6 trig functions. So let's see if you remember what we learned last time. If you are looking at sine, cosine, tangent, let's just start with those 3. What are the definitions of those 3 trig functions according to last class? Y over R, X over R, Y over X. Good. Y over R, X over R, Y over X. And what is R in this? It's the radius, which is the distance from the origin out to the point, right? So we'd need to figure out what R is here. We don't know what R is. Do we know X? Yes. Do we know Y? Yes, it's given to us. So all really we need to do is figure out what the R is. So we can imagine dropping a perpendicular down to the x-axis like that and forming this right triangle. If I write it like this, then here's R. I know this side is 12, right? This side, technically it's -5, isn't it? I mean, if you look at the x-coordinates, -5. When I'm using the Pythagorean identity, it's not going to matter when I square it. Yes?
I was going to say, last class on our reference triangle, we didn't put negatives and positives, but on the homework, it helped me to do that on the triangle. Is that okay?
To do negatives or positive?
Yeah, depending on where it's at, I put it on the triangle. So whenever
That's fine. Like you put -5 here? Yeah, if it helps you to remember. See, all I'm doing with this triangle, the way I look at it, I'm only using this triangle to get r. When it comes down to actually writing this down, I'm actually going to be using this for x and this for y. I'm not even going to be looking back at my triangle for that. But if it helps you, yeah. Everyone good? Okay, so let's figure out what this is. We know that -5 squared plus 12 squared should equal r squared. So that's 25 plus 144 equals r squared. And what is that? 169, which is a perfect square, isn't it? That's 13. So r is 13. And so when we go to get these, y would be 12 over 13. X would be -5 over 13. And then finally, y over x. We could have done this one without doing any work, right? This would have been 12 over -5. Now, the other 6 trig functions are just these reciprocated, right? Do I need to write those down, or are you okay? You just flip those fractions over? You're okay? All right, let's just double check. What quadrant is this angle in? Second quadrant. And in the second quadrant, all students take calculus. Only sine should be positive, right? Actually, sine and cosecant. But you can see here sine is positive, cosine is negative, tangent's negative. So it's matching up with what it should be. Good? Okay. Let's try something a little different. How about if you're asked to find, how about cosine, find exact value, I should say, exact value of cosine of 420 degrees. Okay, so yeah, let's try and figure out where 420 degrees is. It's what? 60. It's equivalent to 60 degrees. So the idea is that 360 degrees would take you all the way around, right? And then another 60 degrees would get you to 420. So you could do it like this. 420 minus 360, that should be 60 degrees. So we're not saying that 420 degrees is equal to 60 degrees. They're not. But they terminate at the same point, or at the same place, the same reference angle. So if I go 60 degrees more right here, this right here, 60 degrees, is pointed in the same direction as 420 degrees. Yes? And we would like cosine of that. Well, so cosine of 420 degrees should be equivalent to cosine of 60 degrees. So I'm not saying that 420 degrees is equal to 60 degrees. I'm saying cosine of 420 should be the same as cosine of 60. Now, do we know cosine of 60? 1/2. How are you getting that? Those are one of the ones you have to memorize, right? Those are one of the ones you have to memorize. So the way I had you do that was to try and remember when you're at 60 degrees, right, cosine is the x-coordinate. And this is smaller. You remember that? So 1/2 is smaller than root 3 over 2. So you had to remember 30/60. If you ever get 30/60, it's either going to be 1/2 or root 3 over 2. What about at 45 degrees? Root 2 over 2. So I don't know how y'all are doing on memorizing those. I'm getting some looks I'm concerned about now. So you have to know that cosine of 60 degrees is 1/2. And you're done. And we're going to get more practice with this today. All right, with this memorizing these? All right. All right. How about this? What is... Find the exact value of secant of 11 pi over 4. Now, I said you needed to memorize these common angles, right? 11 pi over 4 is not a common angle that you had to memorize. You were supposed to memorize 30, 60, right, and 45. Those were the ones. So we need to figure out if this angle terminates at one of those common angles. So let's see here. Also, notice that this is the same as 1 over cosine of 11 pi over 4. Now why is that true? That's the definition of secant, right? Secant is 1 over cosine. So I don't know anything necessarily about secant, but I do know something about cosine. I've memorized the values of cosine. So I'm going to rewrite this as 1 over this. And now let me try and figure out where 11 pi over 4 is. Now my pi over 4s are these guys, right? Those are them? Bless you. And I have 11 of them. So I can start counting my way around, right? 1, 2, 3, 4, 5, 6, 7, 8. I'd be back here. 9, 10, 11. I'm over here, aren't I? This is where I'm pointed. Now, that angle right there is not one of the common ones, is it? It's not. So do you remember what I told you to do in this case, if it's not one of the common ones? Make a little triangle. It comes down like this. Okay, make this triangle. And then, let's look at it over here. Do we know what this angle is right here? Yes, what is that angle? 45 degrees or pi over 4. You can look at it either way. Do y'all want to go to degrees? Pi over 4, doesn't matter?
Degrees.
You want to go degrees, 45 degrees? Okay, and when we say cosine, right, what would cosine of 45 degrees be? Root 2 over 2. Wouldn't it be? It'd be root 2 over 2. So is our answer going to be root 2 over 2? No. Why not? Why is it not root 2 over 2? So we know cosine of 45 degrees is root 2 over 2. But this cannot be the answer. Why is it negative root 2 over 2? Because the angle that, see, we're looking at this angle, right? But we're using the 45 to get us the value. We need to look at what quadrant we're in to figure out whether or not it's positive or negative. So because we're in the second quadrant, cosine is negative there. Right? Only sine is positive. So this should be equal to 1 over, now what did we just say this was? Negative root 2 over 2. Any questions on that? We should probably clean that up a little bit.
Why did we put it over cosine of...
The original problem was secant of 11 pi over 4. So I said, all right, secant is 1 over cosine. That's the definition. It's the reciprocal of cosine. So it's 1 over cosine. And now I wrote down 1 over, now cosine of that angle turned out to use that reference triangle over there, but then I used the sine of the quadrant to give me the negative. Now I just need to flip this fraction, because 1 over a fraction, you reciprocate. So this is really negative 2 over root 2. And then you could rationalize the denominator or just leave it. If you're checking answers in the back of the book, they're going to rationalize.
So we don't have to go past...
You don't, on a test, you can just leave it like that. But again, if you're checking in the back of the book, trying to see if you're getting the right answer, they're going to multiply this by root 2 over 2. Like that. And then the top is going to become negative 2 root 2. And the bottom is going to become 2. and the 2's are going to cancel, and you're just going to get negative root 2. If you came in late, turn in your thing if you have it. I won't take it at the end of class. So, all right, so we have to be a little bit careful, right, with these angles. We have to make sure we know what quadrant we're in, because it has an impact on the sign of our answer, the plus or minus sign of the answer. All right, let's try something else. I want us to find exact value of all remaining trig functions if cosine of theta is 3/5 and we are in quadrant 4. All right, we have not seen a problem like this yet. So what I'm giving you here is I'm giving you the value of cosine at a certain angle. It is 3/5. And I'm telling you that the angle theta is in, maybe I should put that here. Theta is in quadrant 4. All right, that's what I'm giving you. I want you to figure out what sine of theta is, what tangent of theta is, what cosecant, secant, cotangent. So let's start with a picture. We're over here, right? The fact that I'm given that cosine of theta is 3/5 means I can use the definition of cosine, which is what over what? X over r. And I can use that to say that my 3 must be x and my 5 must be r, right? So if I were to come down here and draw a point somewhere in the 4th quadrant, I'm just going to make up the point, then I know that this right here is 5. Agreed? The radius is 5. And what other part do I know?
The x.
The x, which would mean if I came up here and I drew a right triangle like this, I know that this side is 3. Yes? The only thing I really don't have then in the problem is what? Y, right? I don't know what y is. Yes? Okay, so let's label this side y. And I'll even label this point right now. I know that this point is the point 3y, and I'm not quite sure what the y is. Yes? Can you get y?
Yes.
Yes, because I have a right triangle. Looks like this. This is 3, this is 5, this is y. I know that 3 squared plus y squared is 5 squared. So make sure your hypotenuse is this one, right? So that squared plus that squared is this squared. And then I should be able to solve for y. So 9 plus y squared equals 25. And that means y squared is 16. So y must be 4. Actually, y could be plus or minus 4 here, right? But because it's the side of a triangle, we've said it's 4, right? But where are we? We're in quadrant 4. So you might be saying here that y is 4 from this triangle. But in fact, because you're in quadrant 4, y must be a negative value. So y is going to be negative 4. Understand? So y is negative 4.
So it all depends on what the instructions are going to be.
It all depends on what quadrant you're in, yes. So had they put us in a different quadrant, we would have actually drawn our triangle a different way. Like if they would have said we're in quadrant 1, right? Our triangle would have gone like this, and then our y would have been positive, and it would have been 4, okay? So this right here is kind of like a plus or minus, and you're not sure until you look back at what quadrant you're in to figure that out. Okay, so I should be able to get everything else now. Sine theta is y over r, so what should that be for us? Negative 4/5. And then tangent?
Negative 4/3.
Negative 4/3. Good. Negative, which is negative 4 is your y over your x, which is 3. And then the other 3 are just these flipped, right? So am I okay to stop there? Sure. Let's do another one of these. Okay, how about this? How about if I tell you that tangent theta equals negative 4, and pi over 2 is less than theta is less than 3 pi over 2. And you have to think carefully about this one, all right? In the previous problem, I told you exactly what quadrant you were in, didn't I? In this one, I actually give you a range of where it is. So let's see if we can't determine what's going on here. So I'm going to start with the picture. Our angle must be between pi over 2 and 3 pi over 2. Pi over 2 is here. 3 pi over 2 is straight down, right? So I can eliminate these two quadrants, can't I? Eliminate those. So if I'm going to draw this triangle, try and draw a triangle, or a point in a triangle, which of those two quadrants am I going to draw it in? Second quadrant? Why? I heard the right answer, but
it has to be third quadrant because pi over 2 is equal. Oh, wait.
what is, I'm telling you that tangent here, right, is negative.
Oh, okay.
And there's, if we go back to the all students take calculus, all the trig, remember I said last time when we say this, all students take calculus, we're only actually talking about the first 3, sine, cosine, tangent. Right? Okay, so all of them are positive. We're already not in this quadrant, but all of them are positive here, so it couldn't be here. Only sine is positive here, which means tangent is negative, right? Here, tangent is positive, so we can't be here. So by a process of these two things combined, this information combined with this information, we can actually narrow it down to quadrant 2. Y'all get that? Okay, so we are not here. All right, so tangent, by definition, what is tangent? It's what over what by definition? Y over x. So somehow this is y over x. Yes? So I need to look at this negative 4 as being negative 4 over 1. Look at it as a fraction. And then that means you're what? It's y over x? Isn't this y over x? There's a problem. Do y'all see the problem? What's the problem? If we're saying our y is negative 4 and our x is positive 1, then we wouldn't be over here, would we? We'd be 1 and then... So what's wrong? Did we mess up? It all has to do with this negative sign and how negative signs work with fractions. When you write negative 4 over 1, that is equivalent to 4 over negative 1. These are the exact same fractions. So this negative is a float, okay? It can be on the top or the bottom, it doesn't matter. So when you wrote it this way, you would think y is negative 4, but in fact, because of the quadrant you're in, it's not possible for y to be negative 4. Understand? So I need to rewrite this with the negative here and the plus here. These are all these little details you have to pay attention to. So I'm going to draw my triangle. And you don't have to get this perfect. Just make sure you're in the right quadrant. Tell me what the x and y are, because we just determined what they were.
Y is positive 4.
Y is positive 4 and x is negative 1. Do you see my triangle doesn't really match up? It's not like over 1 up 4. But I don't care about that, okay? I can start labeling some sides. This is 4. This is negative 1. And then I could draw that triangle here. Negative 1, 4. And that should get me my r. I should be able to get my r this way. So I know negative 1 squared plus 4 squared is r squared. So this is 17. So root 17 is r. Square that, add them together, take the root. Now r is always positive. That's the good news. All right? So this is root 17. And we're ready to write all the other trig functions. So what is sine of theta? Yep, it's y, which is 4, over the radius, which is root 17. What is cosine of theta? Negative 1 over root 17. And then the other 3, you just flip those over. How do y'all feel about that? Should we do one more? How about I put one up and I'll let you work it. See if you can get it, all right? How about cotangent theta is negative 5 and sine, okay, go ahead. Sine of theta, oh, secant of theta is positive. So I'm giving you the value of cotangent at the angle, and all I'm telling you is that the secant of the same angle is a positive number. Somehow you should be able to nail down the quadrant from that, and then draw your picture and everything else. So see how you're doing. I'm giving you a few minutes to work that out. How about 5 minutes? That sound fair?
getting from here. That, we go and set everything up, right? Yeah.
I'm going to pass around the sign-in sheet because I forgot to do it last week. Sign in for both last week and this and today, please. All right, are we ready to talk about this? Okay, so how many of you feel like you got it? Okay. Help me out with the quadrant. What quadrant are we in?
4.
Why are we in 4? How did you reason through that we're in quadrant 4? Because secant is positive? If secant's positive, that means I can be in one of two places. So here's one way to look at it. Secant is 1 over cosine, right? So that's the same, this is the same thing. Secant being positive is the same as saying 1 over cosine is positive, right? Now the only way that this fraction on the left side can be positive is if cosine is positive, right? 1 is already positive. Divide that by a number. The only way that can be bigger than 0 is if that cosine is positive. So secant being positive means cosine is positive. What quadrants are cosine positive in? 1 and 4. So that already eliminates these two quadrants. Because remember, cosine is the x coordinate, right? It's the x. So we're on this side. Then, this right here, cotangent, is the same as 1 over tangent. Right? And that's negative. So that means that this would have to be negative, which means the bottom would have to be negative. So this is saying tangent is negative. Where is tangent negative? Which quadrants are tangent negative in?
2 and 4.
Tangent is negative here and here, right? So I have to be here. I can eliminate this quadrant. So I have to be in this quadrant. Is everyone all right with that? Now, by definition of cotangent, negative 5 is equal to what over what?
I mean,
It is, okay, I can write as a fraction, but in terms of x and y, what is it? Is it x over y or y over x? Tangent is what? Tangent is y over x, right? So cotangent is x over y. Agreed? So this should be x over y. What do I need to now pay attention to? Whether or not that negative is correct. Is that negative on the 5 or is the negative on, is it negative on the 5 or the 1? It has to be on the 1 because your x coordinate needs to be positive, right? If we're over here, x has to be positive, y has to be negative. So I need to switch this, make that minus, and make this plus. Are we good? All right, so now I just draw my triangle here. What is the point again? 5, negative 1. That's your x, that's your y. Now what? Okay, so use your Pythagorean, you're going to go get r now, right? That's the only thing you're missing is r. So using your triangle, and again, not really caring what it looks like. I know, oops, that's 5 and that's negative 1, right? So we can go 5 squared plus this squared, which would be 26, and then take the root. So this should be root 26. That's your r. And that's it. We have everything, x, y, and r. So what would sine theta be here? So our y, which is negative 1, over r, which is root 26. Cosine theta. 5 over root 26. And then tangent, just out of curiosity, what is tangent theta? Negative 1/5. It's this guy flipped over, right? This one, flip it. That good? You all right with that? I like these types of problems because they make you think a little bit. Okay, we're going to move into the next section. Yeah. And we're going to be talking about the unit circle. So this is 10.5, yeah, 7.5?
Oh, I was about to say.
Yeah, move pretty quick today. Unit circle approach to trig functions. All right, so I want to do a quick recap, okay? Just a quick recap of how the trig functions were introduced to us. All right, the first approach that we took was that we started with the right triangle. We defined this angle in here, theta. We said that this was the adjacent side, the opposite side, and the hypotenuse, right? And we defined our 6 trig functions using SOHCAHTOA. I don't want to write them all out again, but are y'all okay with that? Okay, that was the first approach. The problem with this approach was what? It's limited between angles between 0 and 90 degrees. So we moved on past that, and we said, instead, let's just pick an arbitrary point out here. Let's call this angle theta. Let's call this distance from the origin to the point R, and we have the x and the y coordinate of the point. Then we define our 6 trig functions as y over r, x over r, and then y over x, and then the other 3 are just the reciprocals. And the good thing about this is this allowed us to find the trig functions at any angle. Didn't matter where it was, right? And now we're going to look at the unit circle approach. The unit circle approach is exactly the same as this approach with one little thing added to it. And that's we're going to fix the radius to be 1. In other words, what would happen if I force the radius right here to be a radius of 1? So we look at this circle here with the radius of 1 on it. We call that a unit circle. Unit meaning 1 for r, if r is 1. All right? So let's go back now and imagine we can draw this, and we have this unit circle. I'm going to draw it as a dashed unit circle for right now. See, with this approach, when I pick this point, it could be anywhere, couldn't it? It could be anywhere I want. But if I pick it, this angle here corresponds, like if I move down on this point straight down to where it hits this unit circle, this angle is still the same, isn't it? So if I want to know about this angle, I can just look at the unit circle. I don't have to look at this all the way out to r. So we're kind of just like bringing our focus just right into here. Does that make sense? Now if I do that and I pick some point on this circle, I'll pick it right here. And then I come down here. This has some x and y coordinate, right? That point has some x and y coordinate. But this time the radius is 1. Therefore, the 6 trig functions are going to follow the exact same formula as this one, with the exception that r is 1, right? Always. Well, on the unit circle. If we're going to talk about the unit circle approach, we're fixing r to be 1. What's nice about that is then what is sine of theta? It's just y. And what is cosine theta? X, and then what's tangent theta? Well, it's the same, y over x. But do you see that we no longer have the radius to worry about? So it's just the y coordinate. Sine of theta is just the y coordinate. And cosine of theta is just the x coordinate. So long as you are on the unit circle, I mean, you have to be on the unit circle for this to work. All right? So let's try and see if we can't use this to help us memorize those common angles. Let's see here. So let me go, and let's just talk about the first quadrant. Just going to look in the first quadrant. And I would like us to look at the unit circle. So I'm going to put this as a radius of 1, okay? And let's start with 45 degrees. Do you remember what cosine of 45 degrees was? Okay, so cosine of 45 degrees was root 2 over 2. And what is sine of 45 degrees? Root 2 over 2. And you were told that, right? You were given that information, told, hey, that's, you can prove it. I didn't prove it. I should have proved it, but I didn't. Right? So that was given information. So look, if I come right here to this point right now and I ask you, what are the x and y coordinates? Can you tell me what the x and y coordinates are? So very important. I'm on a unit circle, right? And since I'm on a unit circle, the x coordinate is what? Cosine of the angle. So the x coordinate should be cosine of 45. And what is cosine of 45? Root 2 over 2. What is the y coordinate? It's sine of 45, which is root 2 over 2. You see how that works? Now you have to memorize that. All right, let's try the 30 degrees and 60 degrees. How about at 30 degrees? Do you remember what cosine of 30 degrees is? And do you remember what sine of 30 degrees is? Well, you should remember that it's going to involve 1/2 in root 3 over 2. You should remember that. It's just a matter of figuring out which goes with which. So I think I've talked about this several times now, how I've got it, how I memorized it. Do you remember how I memorized it? Or how I told you might be helpful? If I'm trying to figure out the x, right? X is going to be the cosine one, right? So cosine is the x value. That's going to be the distance from here to here, which is the bigger of the two numbers, right? Because this distance from here to here is bigger than that one. So what is it? Root 3 over 2. Root 3 over 2. And that means that the other value has to be what? 1/2. So that comes from the cosine, and that comes from the sine. We never put these here. Root 3 over 2 and 1/2. And then we have 60 degrees. And what's going to be the difference here with the 60? They switch places. So this is going to be 1/2 root 3 over 2. Y'all good? Are you sure? No questions? Okay, there's some other points on here I want to label that I have not labeled, but I've got some arrows in the way. So may I erase this? We're good with that? Okay, how about the point at 0 degrees? How about at 0 degrees, right here? What's the point here? What's the x-coordinate? The x-coordinate is what it takes for you to go from here all the way to here, right? Which is 1 because you're in a unit circle. And then what's the y-coordinate? 0. Okay, how about this point up here?
0, 1.
0, 1. Because your x is 0, but your y is 1. So what you want to do at this point is you want to memorize this first quadrant of the unit circle as soon as possible. You want to have this like almost burned as like an image into your head. Also remember that all of these could have been given in radians. This could have been pi over 6, right? 45 is pi over 4. And 60 degrees is what? Pi over 3. And of course, straight up is what? 90 or pi over 2. And then this is 0. All right, now let me show you how this is going to be very helpful to us. Let's say you have that memorized. Okay, there it is. Let's say that all you have to do is close your eyes and you see this, okay? I know you may not be there yet, but let's just act like we can see this in our heads, all right? Let me ask you some questions. What is sine of 90 degrees?
0.
Okay, so if you go back and you look at this, what I just erased here, I said that sine of theta is y, right? And cosine of theta is x if we're on the unit circle. Yes? That means that all of these points here correspond to cosine of the angle and sine of the angle. So this right here is cosine of what angle? 0. This is sine of 0. This is cosine of 30 degrees or pi over 6. This is sine of 30 degrees or pi over 6. This is cosine of 45 or pi over 4. This is sine of, right? So the x and the y coordinates on the unit circle are corresponding to the cosine and sine values at that angle. So when I say sine of 90, what you're doing is you're saying 90 degrees. What's my y coordinate? Why am I saying y? Because it's sine. Okay, so y coordinate, I'm up here, right? I've got to go up 1. The answer is 1. You see that? Up there, the y coordinate. All right, so what is secant of 45 degrees? Okay, so 45 degrees, right? Root 2 over 2, root 2 over 2 is what I'm seeing. Secant is the reciprocal of cosine. So cosine, well, it doesn't matter because they're the same, right? But it would have been the x-coordinate, right? It would have been the x-coordinate. So it would have been that one flipped, right? So it should be 2 over root 2. I'm trying to show you this the way that I think you should get to a point where you're seeing it. Let's try another one. How about cosine of pi over 6? Pi over 6. I'm visually, I've got, okay, root 3 over 2, 1/2. Cosine's the x, so root 3 over 2. That one right there. So that's why I'm saying the sooner you have this burned into your brain, the better. What would cosecant of pi over 2 be? Pi over 2? Cosecant, right, is the reciprocal of sine. Sine is the y coordinate. So the sine was y, 1, and I'm doing 1 over that. So 1 over 1 would be 1. And while we're here, what would secant of pi over 2 be? Ooh. Okay, so I'm at pi over 2, right? So I've got my visual. I go up to pi over 2. Secant is the reciprocal of cosine. Now, what is cosine of pi over 2? Well, that's the x-coordinate up there, which is 0. And I've got to do 1 over that, right? 1 over 0 is undefined. We haven't seen that yet. It's actually undefined. That means, and this is coming, okay, not today, but later. That means if we look at these 6 trig functions, there's some trig functions that we can't plug things into, which means that they have domain issues. Some of them are fine, some of them aren't. And we'll be talking about domains and ranges, and then we'll be graphing them. We'll see what do they look like if you graph them. But that's going to come later. All right, any others you want me to go over? How about tangent? Let's try tangent. What would tangent of 0 degrees be? All right, so tangent by definition is the y-coordinate divided by the x-coordinate. Yes? So I go to 0 degrees. My y-coordinate is 0, my x-coordinate is 1, right? So I'm doing the y-coordinate 0 divided by 1, which is 0. So it's okay to have 0 on top. Just can't have 0 on the bottom. What is tangent of pi over 3? So I'm going to go to pi over 3, which is 60 degrees, right? Go up there, and then I take a split second to think about the x and y coordinate. The x coordinate is 1/2. The y coordinate is root 3 over 2. Yes? 1/2 root 3 over 2. And I'm supposed to take the y and divide it by the x. So I've got root 3 over 2 over 1/2. The y divided by the x. And then I can do the flip reciprocal thing here. This is root 3 over 2 times 2 over 1. And the 2's cancel, and I just get root 3. Root 3 over 1, which is root 3. So tangent of pi over 3 is root 3. What do y'all feel? I mean, how do y'all feel about this? It's all right? What's cotangent of root 3, or pi over 3? What's cotangent of pi over 3? So we go to pi over 3, and instead of y over x, I'm doing x over y. So I'm doing 1/2 over that, root 3 over 2. One half over root 3 over 2, right? This instead of this. So how does that change things? It's 1/2 times 2 over root 3. 2's cancel, you get 1 over root 3. So it was this one flipped over. But I was acting like we hadn't done this yet. All right? Let's continue. I stopped using letters. I'm just going to continue just doing examples. How about this? What is sine of 2 pi over 3? So something's different now. What's different?
You're going past this.
I'm going past this 90 degrees, right? I'm going past this. So I'm now over here, right? I'm trying to tell you right now that all you need to do is memorize this first quadrant. If you can get this first quadrant down, I think the rest of it will follow pretty naturally. And let's just see why the rest will follow naturally. If I continue this circle around like this, then start to draw in my other angles in here. Let's take care of that blue one in here like this. Yeah, the only thing that happens, yeah, it's a reflection. So check this out. This point right here, it's not really a good picture. Oh, let me try that again.
Or we flip, like, we looking into flipping the denominator values too, or we're just gonna pop it on over, so that one's still gonna be root 2 over 2?
Let's think through that, okay? And the way to think about this is, look at this point right here, right? This is the x and y coordinate. That tells you how far to go out and up, right? I actually want to be here now. So I still want to go out this far, but I don't want to go out this way, I want to go out this way. That means my x coordinate needs to be negative. Then I still want to go up to the same height, don't I? So my x coordinate should be negative there, my y coordinate should remain positive. So it's going to be these two same numbers, but with that one negative. Negative root 2 over 2, root 2 over 2. You following?
Yeah.
So look, same y values, so your heights are the same, but your x values are opposite. Now, we didn't say what angle this was. What angle is that? Pi over 4, 2 pi over 4, 3 pi over 4, right? Now, in terms of degrees, what is it? 135. Yeah. Now, there are two other angles here. There's this one and this one. So let's start with this green one up here. What's that angle in radians? So here's pi over 3. Let's try it this way. This is pi over 6, right? Isn't this 2 pi over 6? 3 pi over 6? 4 pi over 6? 5 pi over 6? 6 pi over 6? This is why I was trying to get you to count before when I first introduced this. Pi over 6, 2 pi over 6, 3 pi over 6, 4 pi over 6. This is 4 pi over 6. That fraction reduces. 4 pi over 6 is 2 pi over 3. So this is 2 pi over 3.